Hi, and welcome to an intro to DevSpace, the cloud-native developer tool for Kubernetes. DevSpace automates cloud-native deployments and enables cloud-native development. Let's take a look at what that means. Deploying a project to Kubernetes manually requires a lot of steps: building Docker images from Docker files, pushing images to container registries, and running several commands with tools like kubectl. This is not only time-consuming and error-prone but also very repetitive. DevSpace provides a better way to deploy to Kubernetes. With the command line tool of DevSpace, developers can deploy to Kubernetes with just a single command, DevSpace deploy. That is much faster and easier than remembering all the deployment steps and allows developers to test their code much quicker and easier in a production-like environment. DevSpace automates all deployment steps. First, DevSpace builds all necessary Docker images. To speed up the build process, DevSpace runs all build processes in parallel. Images can either be built with a local Docker daemon or with Code directly inside a Kubernetes pod. DevSpace supports even advanced build features such as multi-stage builds. After building the images, DevSpace automatically tags each image with an auto-generated tag according to a tagging scheme of which you can configure. By default, DevSpace uses a random string, but you can also tell it to use the current commit hash, the current timestamp, and more. DevSpace then pushes the newly tagged images to their respective container registries using the user credentials stored on your local machine. If you are able to push to a private registry using Docker, DevSpace will also be able to push to this registry. For private registries, you can also tell DevSpace to automatically create image pull secrets in your Kubernetes cluster. After pushing all images, DevSpace starts the deployment of your project. In a microservice world, most applications depend on other services to work correctly. That's why DevSpace allows you to define dependencies between different projects, even across multiple Git repositories. After resolving the dependencies for a project recursively, DevSpace deploys all dependencies in a bottom-up fashion. That means that after all dependencies are up and running, DevSpace will continue deploying the project you are currently working on. DevSpace supports many types of deployments, including Helm charts, plain Kubernetes manifests, as well as deployments with Kustomize. A project can define multiple deployments which will be executed one after another. After everything is deployed, DevSpace runs several automated tests to verify that your application is up and running. If not, DevSpace will print the logs of failing containers, list services without endpoints, and show other valuable information from the Kubernetes API server. The second major feature of DevSpace is its development mode, which allows cloud-native development directly inside Kubernetes. When running DevSpace Dev, DevSpace runs similar build and deployment steps than when running DevSpace Deploy. However, DevSpace applies certain overrides for development. You can, for example, tell DevSpace to use a different Docker file for development. Or you could tell DevSpace to simply override the entry point of the image you are currently working on. This is often helpful, as you might want to start your application with a different command than in production. Or you even want to start your application manually. In this case, you simply tell DevSpace to override the entry point with a sleep command. After building and pushing your images as well as deploying your project and its dependencies, DevSpace starts the development features. First, DevSpace starts port forwarding for the ports you specify. This allows you to access your services and containers directly via localhost, which makes it very easy to test your application in the browser or to attach a remote debugger. Then, DevSpace starts the bidirectional file synchronization. That means that DevSpace watches your local file system as well as the remote file system of the containers for changes and is able to synchronize file changes in real time. This is especially handy for using hot reloading during development. The last step for starting the development mode is either to stream the container logs or to open an interactive terminal session which allows you to execute commands directly inside the containers running within the Kubernetes cluster. In this example, we configured DevSpace to override the entry point of our main Docker file with a sleep command, so that we can use the terminal proxy to start the application manually during development. Ideally, we want to run DevSpace directly from the terminal of our IDE. Getting started with cloud-native development is as easy as running DevSpace dev and then entering a command to start the application itself. We can see that we are demonstrating this with the Node.js application that is started using the command npm run dev. After running this command, the application is running inside Kubernetes and is listening on port 3000. If we take a look at the code, we can see that this application is a simple Hello World web server. Thanks to the port forwarding, we can easily access this application via localhost port 3000, directly from our browser. There it is, Hello World. Now let's start developing this application. We can see in the IDE terminal that the application has been launched together with nodemon, a hot reloading tool for Node.js. Nodemon will automatically rebuild and reload our application when it detects that a source code file has been changed. So let's change the output of our application to Hello DevSpace. Remember, nodemon is running in the remote container and we are making this change on our local file system directly with our IDE. This is where the DevSpace code synchronization comes in handy. After saving the file, DevSpace automatically detects the code change and updates the source code files within the container accordingly. We can see that nodemon detects when DevSpace updates the index.js file within the container. This triggers nodemon to rebuild and restart our application. All we need to do now is to refresh the browser, and we'll see that our changes are already live.